So today we're going to continue the lecture lab that we started last time, which was on Wednesday, right? So we're doing the observer pattern. So we're into design, and so today we're going to continue the lecture lab that you started, and hopefully you're going to finish it today. So we're kind of nearing the end of the term, and so really here's the outline for the rest of the course. We're going to finish today the observer pattern. We're going to do the composite pattern and the iterator pattern in sort of the next 4 lectures. And then for each of these, there's going to be like one lecture where I'll introduce the pattern for you. And then there'll be a second lecture where you get to practice it in the lecture lab. And then the last 2 days of the term are really dedicated to the project demos. So really there's going to be overflow from the labs. So if you have a partner in the other section of the course, or if you can't make the demo in the lab, for some reason, then essentially we're going to schedule you to come and give the demo here in the class and lecture. But if you don't have a demo on that day, you don't have to come. Okay? So unless you want to watch the misery or / elation of other people as they present their projects, you don't have to be here. Okay? So really these 2 days are dedicated to demos. And if you come to demo on one of those days, I'm not going to put you here in the pedestal and have, expect a presentation on the big screen. So I'll just walk around the lecture hall and essentially go to each group, and then the groups will present their parts. So that's the outline of the course. There's, just as a side note, the Java tutorial is tonight. It's at 5 p.m. It's going to be in this room. And we're going to get it recorded. So you don't have to come. It'll be online. But of course, if you want to actually participate, ask questions, you can come to the tutorial. It's an hour long. It's led by TA, who's pretty good. Who's good at giving talks, good at explaining Java. So come if you really are struggling with some Java concepts, right? So if you want to ask more about, syntax, if you want to ask about, how do I declare a variable? How does a loop work? How do I write down a loop? Some really basic things and more advanced concepts, then you should really come for the tutorial. So the last thing that I have on here is a set of project tips. I decided to write these down. So there's a bunch. I'm just going to kind of go through these, because a lot of these are coming up on Piazza. And so if you've been active on Piazza, these are probably pretty obvious to you now, especially if you're into like task 4 or 5 or so. If you haven't started, hopefully these will make it easier for you to start. So the one thing to note about the tasks on the page is that they're not of equal difficulty, right? So task 1 is not going to take as much as task 2. Task 2 is not going to take as much as task 3. They're really kind of all over the place, right? So for example, determining the route between the Waldo and the user, that task is way more difficult than all the other tasks. Okay, as some of you are finding out right now. So like getting your computer to run Android emulator, hopefully that's like under an hour. Depends on your computer, depends on lots of things. But you can get that done fairly quickly. The other tasks may be much more advanced, right? And so you may find them more difficult. So what that means is that it's very difficult to plan your time. Right? You can't really say I'm going to spend an hour on each task, and so I should dedicate like a day to the project or something. Right? It's not going to work like that. Okay? The other thing is that the project page gives you guidelines, but not instructions. Okay? So we don't tell you what to do. We tell you what we want the outcome to be. Right? In the end, your app should function in the following way. Right? And that's what I demoed for you. But actually, the kind of code that you need to write on the back end to make that happen, that's completely up to you. Right? So the tasks that we give you they're structured as guidelines. They're structured as pointers. Right? So if you want to get the GPS for a Waldo, here's the thing you should look up. Right? And then it's up to you to actually figure out how to use it. And there are multiple solutions to this project. So there's not like one solution to the project. Okay? So don't treat them as instructions. Because they're not, right? Like if you try to follow them, you'll be like, this doesn't make any sense. I don't know what to do next. Okay, well that's because they're not instructions. It's not a recipe. Third point is about searching for examples. So you should, and we encourage you to go online and look for code examples, because this Android library is huge. There's a lot of things to learn. There's a lot of things me and Gail don't know about it. And so this is very typical software development, where you say, I want to get the GPS for my Waldo. How do I do that in Android? And you have to Google for it. You have to search for code examples, possibly. And then you try to adapt those examples to your context. Now, your initial intuition might lead you to believe that if you find a large piece of code, that's great. Right? In fact, that's usually not what you want. Usually what you want is a very simple example of the functionality. So if I find a fully functional Android application, it's going to be very difficult for me to take any code out of that application, right? Because it's just going to be very intertwined with the logic. So try to find really small examples. Okay, so you really want like 3-4 lines of code that you can adapt and you can experiment with, and then plug into your system. If you find a large piece of code, like 50 or 100 lines of code, there's no way you can put that in your app. A little bit of code at a time. So rerun very often. Right? Every time you change your code, there's the potential for introducing bugs. If you introduce a bug and it was 200 lines ago, then good luck finding that bug. Right? So you want to write a piece of code, run the application, make sure that the code is doing what it's supposed to, and then add more code. So it's very iterative. Right? So we run our applications all the time. This is why it's very easy. There's all these shortcuts in Eclipse for running your unit tests, running the app, right? Because you run them constantly. You add a little bit of code, you run the app, you see what happens. Okay, so it's going to be very challenging for you to debug an application that has lots of new code. Because if there's an error, it could be anywhere, any one of those lines of code. Use a debugger. System out print line. So this is pretty obvious, but you're going to have bugs. There's no way to avoid them. You're going to have misunderstandings about how the API works, for example, right? So you're expecting it to do one thing, it's doing another thing, your program crashes. So you're going to need to debug, right? It's just a fact of life, fact of this project, okay? So you need to use the debugger, and you need to find out what goes on in your live execution. So setting breakpoints is one way of getting insight into what the state is of my program. But then just printing it out into Logcat is another way of doing this. One note about Logcat is that, of course, if you set it to verbose, then you'll see just a huge dump of messages. Right? It's just Android is generating messages constantly. So if you print something out to Logcat, it's going to be very difficult for you to find that message unless you really browse around and try to search for it. So that's just a warning. And then the final note here is that the message that you get if your program crashes is a little bit counterintuitive. It says Waldo unexpectedly stopped running or something similar. So what this means really, this is code word for your code crashed, you have a bug in your code. Okay, so if this happens, you should really be looking at Logcat for a potential stack trace and maybe exception error output. That would lead you then to figure out which line of code is the culprit, right? Where the bug surfaced and your program crashed. So try to keep these in mind as you work on the project. Okay, it's a big endeavor. There's not a lot of code that you have to add, but you have to be really smart about how you do it, because the project is fairly large and it's challenging to debug it. Okay. Any questions about these sorts of things or what we're doing this week, design patterns? Great, let's switch over. So last time we talked about the observer pattern. And the observer pattern basically looks like the following. You have some class which is observable. And it's observable because it contains some data that observers are interested in. So observable maintains some data, and then there's the notion of an observer. an observer has an update method that is called whenever the data is changed. And usually the way you invoke this is by running some method inside of observable, like notify observers. Right, so this notify observers, what this code does is essentially iterates through all of the observers, for each observer, call notify. And so the observable knows about multiple observers. So the relationship here is it's unidirectional. And the observable may know about 0 more observers. So this is our pattern. And then concretely, you're going to extend observable in some way and implement or extend the observer. And you may have multiple observers. There might be multiple classes that might be interested in this data. Right? So the example was the spreadsheet where my cell is my observable. It's my subject. And the cell contains some data, right? It contains some number, perhaps. And then you have some set of observers that are interested in looking at this data, in receiving updates about this data. And those observers may be graphs. Right? So you may have a bar graph, you might have a line graph, other things. Maybe a formula, like a formula that updates whenever you update the cell. That may be another observer. And so each of these implements its own update method. And whenever I change the cell propagates this change to all of the observers. Okay, that's basically the pattern. So this makes it very easy for me to add new observers into the system that respond to changes that the observable goes through. So the lecture lab. So lecture lab that we started last time was the following. And basically, I'm going to have you continue on this lecture lab, except that now I actually give you a little design pattern on the bottom. So the way you should instantiate the observer pattern is by using the internal Java library observable and observer classes. So observer is an interface, observable is a class. And so you should make sure that sprite extends observable, and then invader extends sprite already in the system. And then you should add a new observer called console writer, right? So this is really your task, right? So this statement of the lecture lab translates into the following diagram for Space Invaders Refactored. Okay, so please spend the next maybe 10, 15 minutes or so implementing this design within Space Invaders Refactored. And then we'll go over it, and then I'll try to implement it in front of you. Okay, and if you have any questions, just raise your hand. I'll come by. And one thing I should note, you should just Google for class observable Java and then the interface observer in Java. And then you'll get the documentation for these. Right? They're not going to be as straightforward to use as the ones that we saw in Alarm System. So look at their method calls and figure out how to actually use these, okay, in your project.
default background application you're running signals from your memory, but there's no way you're using settings.
We should play a concert.
Yeah, it's good to have.
Oh, this is the one I made. Oh, wait, I see why. Yeah, I don't think it is built in. I mean, it's built in, but I don't think it's like.
I don't want it.
Why are all these
Yeah.
Say like really?
That's cool too. I was surprised. I was doing some lessons now.
School association. So it shouldn't be that.
Yeah.
That's not a
Hell. So I don't know how it's so fast.
Yeah, so what's this all
What I like on Bruce I had a screen this, and then my screen decided to always make I got the whole pixels died. It's like a mass suicide. And I go to jump. The screen is over his eyes. That was that project. I think it's I had no double the size. I had like 2 inches. I had so much bigger. What you can do to try and we don't know how to pass it on, just uninstall it. Yeah. Yeah, that installation that will work, whereas I'm doing now, if I actually save well, it's the last year. Yes, because all the
you have to test the thing here. Find your ones that has like each. So observe with one inch.
Make sure you install the right one.
Yeah, something you can see out.
You do have the correct install design. I don't remember what year. I don't think we should have it do this one.
Yeah.
Then it's probably just you download a Apple version because actually it's Apple.
So, what I would say if you go to travel my master you don't have to come out to like or stiff spray.
That method makes sense.
Or not all of it.
Like you're saying, have this.
Yeah, it's harder. I just think
So I guess we should have it's like 2 weeks. We're gonna do this entire lecture. So it's not gonna be late on this one. We actually just doing this one. Because we're doing this one, I believe. Just do it. Also explain. So what it is, the lecture I like to be is that I can ask questions and stuff. But this, I can't ask questions, I can't do it, so you can't ask questions.
anyway, what it does is it actually processes that URL. Then you and it stuff. Yeah, you like it just has to like it'll process a request on the website. Whatever the web service This is what happens. No, you can't.
You should give it its
But this is the default tag.
and this is one thing. It is just calculation again. Ya estoy, pero esto es un bullying. Chequea recién.
This is the first part of the task.
I mean, it
So there's got to be you're already using that it gets a bunch of this the number response. Just to make sure you have internet. That's really amazing. Like I got off skiing so yesterday. I'm here.
I hate to see that time. Yes. What's You were yeah. Is that what you were David I guess when they program this and like
Which methods have you already done?
I will probably tell you a couple.
They're not updating.
Oh wait, no. Wait, do I need a wall of service? Wait, it's okay. I don't need a wall of services.
Those are already so you're inheriting. So
Always the one continues to do where they are. Trying to revive it, basically.
It does update it.
this. Go to the keyboard. I was like, fuck it. I don't want to bother with this shit. This is actually working. What's your job? JSON object. I remember when I was. But there we go.
Well, you don't understand. It's actually a man standing. Oh, really?
Actually, I am.
Right, yeah, you told me. That's cool.
Giant button crashes. They came up with this giant door. It says battery JSON. There's a giant door just in the sky. Which is so late. You'll write like it does be all in one moment no show it's just JSON, it's just this whole they use and a ring cars that drive by. No, it's not really but it looks like it's like every single time that's why it just so I'm just fine. I guess it's I don't have very many. I have up to 10. We're going to get tested. I've been so long. Giant. It's like the hardest one. The next question is, would you even hear the notes so low?
What are you doing? Like once you start
You're running together.
So everyone's making a very similar mistake. So when you're extending or implementing something, you're inheriting functionality. Okay, so the fact that Sprite extends observable means that you could do within Sprite this that notify observers. So you don't have to create your own notify observers. The functionality already exists as part of observable. Okay, so by inheriting it, you can reuse it. And that's the beauty of this pattern, right? So you have to write very little code to actually add this thing in. Okay? You don't have to add a list of observers. That list is already part of observable. And you don't have to add notify observers to Sprite or Invader. This method is already an observable. So just use it.
Run it once and you have to query that's what my TH will run it once and then switch over charged. Yeah, that game actually. It's so complicated. It's like when it's plugged in,
Did you,
when it died.
did you,
You know what? I thought it would be a pretty good game.
Cool. Yeah. Now just change. You run it. To just say that action
This is the first time we saw this, or did I just not
Did you
know what
actually?
to do?
It was a good one.
Yeah.
Where did I last
The manifest reads itself.
Yeah, I saw the video.
Okay, so let's try to solve it. How many people finished and got it to print something out? 2, 3? Good thing we have the lecture lab. So what am I doing here? Treat this class diagram as a blueprint for what I want to implement. Okay, so there's the observer pattern at the top, and then down below this tells me how do I introduce this pattern into my code. So to start with, I'm going to say, okay, I have observable. It needs to be subclassed by sprite. So I go to sprite, and I say that sprite will extend observable. Observable from Java util. Step 1, right? So now I have this relationship, right? Sprite extends observable. And now I can use all of the methods defined inside of observable. So in particular, I need to somehow notify my observers. So the notification needs to happen somewhere where the collision is detected. So there's a couple of choices. You can either do this in SI game, because SI game does collision checking, like here, if target.collided with, right? Or you can do it inside of Invader, because Invader has collide with method. So let's do it here inside of Invader. So I could just create a Boolean ret and return ret. So I just memorize the return value. And then my next step would be to say if ret, meaning if I collided with something, then I want to notify my observers. My observers, because an invader is observable. So I can just say this dot notify observers. Okay, so if there's a collision, I'll notify the observers.
You only want to check what it's designed to though. Won't that check if there are any collision at all?
I'll check all of the collisions, but in the scope of this game, it only checks it for missiles. Right, so I'm using some information that I know about the game to make this change. Now, one thing you'll note is that if I look at observable in the Java doc and look at notify observers, then the documentation for this says if this object has changed as indicated by the has changed methods. Right? So this basically tells me that I need to make sure that the object has changed in some sense. And for this, I need to use the setChanged method. So I need to mark this observable object as having been changed. So this is a slight quirk on the basic observer pattern that we saw in alarm systems. This is slightly more complicated, where I need to first set changed on my observable, and then I can notify my observers. Okay, so the protocol for this observable and observer is slightly different. And the way you know this is you have to read the documentation. Okay, so I added this code to my observable. So now my updates, my collisions are flowing to observers, whoever they are. Except I don't have any observers in my system, right? Because I haven't implemented the second half of this diagram. So the second half of this diagram, I need to add a console writer and make sure it's an observer. So that's a new class. I'll go to the UI, create a new class, call it collision observer. And my collision observer will implement observer from Java util. So if it implements the observer, it needs to implement specific methods, in particular the update method. The update method for collision observer is very simple. According to the instruction, just print something out. So I'll just do system.out print line. Light it with a missile. So that's my observer, and I have my observable passing updates to my observers. But there's one piece missing. What's missing from this code right now? I have an observer, right? I created a new class. I make sure that my invader notifies observers. What am I missing?
Console writer is not initialized.
Console writer is not initialized. Well, that's a good observation. I have a collision observer, or console writer. I haven't created an instance of my observer, right? So how can I ever call update on this observer? I need to at least create it. Okay? So, but creating is not sufficient, right? What else do I need to do after I create it? I need to make sure that this observer is associated with my observable. So my observable needs to add this observer. Okay? So I could do this in a bunch of places. I'll just do this in the constructor of my invader. So I'll say this dot add observer. And here I need to add an instance of my collision observer. And I'll just create one. No one said that I need to have a single collision observer for all invaders. So that is all. That's all the code that I needed to add. Yeah.
Wouldn't initializing collision observer every time when the invader is initialized be inefficient?
Yes, this is definitely an inefficient solution, right? Because collision observer, I really don't need one copy per invader, right? I need just one. But this works. This is okay. I'm not going to have a million invaders, right? So if I run the program now, so now I need to hit an invader. All right, so my invader's hit. If I look at my console, collided with a missile. Okay, so this basically demonstrates how to use the observer pattern. So the key thing is, there's like 3 steps, right? 1, create observer, plus add to observable. 2, notify observers on some change in state. So once you've created these subclasses and you've implemented observer, you really need to make sure to do these 2 final steps.
So what is the advantage of following that design instead of just saying, changing the collider with method and saying that print when it collides with a missile?
Right, so what is the advantage of having a separate console writer that has that functionality, right? So the advantage here is that the console writer is a modular component of your system. The way to think about this is that, this is a very simplistic example, but the console writer might have, done a bunch of other things in its code base. Maybe it's a 1,000-long program that sends email, on some aspect, when some aspect changes. Or maybe there's a bunch of other observers here that are interested in that state. Right, so the question is, how do you programmatically add these observers to respond to that change, right, dynamically? So for example, when I create a new bar graph, right, that new bar graph needs to be added as an observer for the cell that it's responding to, right? So I need to dynamically add this observer. So in this case, the observer is kind of hard-coded, but in practice, these observers may be added or removed from the list of observers, right? So that ability is really important. And then also because it's a separate component of the system, right? It's supposed to somehow respond to the changes, and the system should not have a strong dependency on it, right? Because there might be multiple observers and you don't know who they are ahead of time. Okay, great. Next pattern, Monday.